Hello and welcome to this clip going through a transition metals question from the specimen paper in periodic table elements in physical chemistry. This is available on the OCR website. I've provided the link underneath the screen on this clip, but I'll just take you through this one because it's one that is the style where quite a few students can sometimes get a bit muddled up, particularly when it's quite applied in the way it's been worded, as you can see. So the advice will be to read the question throughout before attempting to identify A to D. So when I say read the question throughout, I'm referring to reading all the information in the box first, so you can sort of absorb it as a whole. So let's go through it first of all. 4.800 grams of a green hydrated crystalline solid A are heated in a crucible to remove the water of crystallization. So this obviously suggests it's got XH2O in the formula. And the fact that it's got 1.944 grams of water means the number of moles of water can be calculated. So this must mean that B is the anhydrous salt. So the next two lines give us a bit of information about B. So we can ignore for now the 32.8% by mass. The most useful piece of information we've got to go on from here is that all of B is reacted with silver nitrate to form 7.695 grams of a white precipitate, C. Now obviously from your first year chemistry you'll remember that this is a typical test for halide. So C must be a silver halide. The fact that C is a white precipitate, as opposed to a yellow or a cream precipitate, would suggest that it's silver chloride. Now obviously that wasn't terribly difficult, so if you look at the question, they're not asking for the identity of A, B, D and E, so don't waste your time writing down the fact that C is silver chloride. You can use this though when trying to identify B and A. So if we allocate M, shall we say, to represent our transition metal, B is likely to be a chloride of the metal M. So if we work out the MR of silver chloride, it's 143.4 grams per mole. So we need to work out the number of moles of silver chloride in 7.695 grams. So for now I want to keep my calculator value, so it's 0.05366 10878 moles. So, if I move the page down a little bit to make some room to do something with this, if we look at the ratio of chloride ions to the ratio of number of moles of B, you divide one by the other to get approximately 0.335. So moving the page down to make some more room, so let's collect the information that we've got so far. So the bit I'm talking about here is slightly off the screen, so if you need to rewind the clip a little bit just to remind yourself, A can be also written as MCl3.XH2O because A is the hydrated version of B. We're also told that it contains 1.944 grams of water in a 4.800 grams sample of A. So we can work out from that we have 0.108 moles of water present in that sample. So moving the page down a little bit further, so by difference we can now work out the MR of B, because A, which is the hydrated version, take away 1.944 grams of water, so 4.8 grams of A, take away 1.944 grams of water gives you the mass of B. Divide that by 0.0180, which are the moles of B that we had stated in the question, and that gives us 158.6 grams per mole. So if we take the 3 Cl minuses section of B, that's responsible for 106.5 grams per mole. So that leaves our metal having an atomic mass of 52.1 grams per mole, which by checking with the periodic table, the closest candidate is chromium. So moving the page down further again, we can write B as CrCl3. So the next thing to do is to work out the moles of chromium chloride to the moles of water, which gives us 0.0180 to 0.0108, which gives us a 1 to 6 mole ratio. So that means we can now write the full formula for the hydrated salt A. Okay, so that's our calculations part. Now what we can work out is what D and E might be. So let's go back up the page a little bit. So it says the green crystalline solid A is dissolved in water to produce a green solution containing a complex ion D. So the act of dissolving it in water is going to mean that there's going to be 6 water ligands surrounding the chromium central metal ion. So, going down the page, that allows us to put the hexaquachromium ion. And going back up the page again, it says when aqueous sodium hydroxide is added to a solution of D, a grey-green precipitate E is observed, which dissolves in aqueous sodium hydroxide to form a green solution. Now, your knowledge of the reaction of hydroxide ions with transition metals should lead you to think that we've got a chromium hydroxide of some kind. So the second part of the question is actually handled in a separate clip called Transition Metals Stereoisomers and Level Response Question.